Welcome to episode 4 in the Creating a Shadow Switcher series. The game's creator has granted me permission to post this content. In this video, we are going to expand upon what we did in the previous video by creating the player object and even introducing some basic collision detection. Starting with this video, I will post the source code on my GitHub at github.com/GrayDefender. Alright, to sort of recap where we left off from the last video, let's go ahead and run our program real quick, and you'll notice we have some of the map displaying. There's a whole lot of different directions I could go in this video, but the first thing I want to do is just resize the window, and to do that we'll go into our settings, and I have a screen width and height variable that is being utilized, I believe, in the game object. I'm going to make it 1200 by 800, and I just didn't bother to do that in the last video. It's running short of time, and I'm going to hit save, and I know there's an auto save feature, so let's check that, and I still hit save out of paranoia. And we're going to go ahead and run the program again. And now we see most of the map. I need to go a little bigger, I think, on the right here. I'm truncating. So let's see, what, maybe 50 more? What do you think? Go to settings, maybe 1300 just to be clear. And run that again. Okay, that's most of the map. We could snug that up. 50 probably would have been good. So I know the colors are hideous. The green is pretty ugly, but let's look where this screen width and screen height just to show where that is. Right there, it's referencing settings.screenWidth, settings.screenHeight, and that's what sets up the width of that window in our game class object. So right now we don't have very much to it. Then also we have this block object, which all it does is it positions a block on the X coordinate and a Y coordinate. It's accepting a path right now of where to find the tile to display on the screen. And it's very short, and it just sets the X and Y coordinates to the X and Y that's passed down. And then it creates an image based on that with these commands here. So this command here actually loads a image from a file, essentially, the path where you give it. And those files are located right here. There's a PNG, I guess I have one as a PNG, the other is a JPEG. And then someone made a comment on the last video that probably shouldn't use JPEG because it compresses and could change those characters, those pixels, which I think is a good point. But I'm not experiencing that here. Anyway, so the first thing what I wanted to do is go ahead and create the player object. So I thought from here we could generate a player that we can move around. And so to do that, we're going to create another class called the player class. We're going to do new file player.py. And if we wanted to, we could easily copy just to get the, on the left side here, or the right side, copy this from block and paste it over into player. Don't really need random in here. Don't need it here either, but it's there. But that's probably for later. And then it's almost the same. So we have a X and a Y. We don't need tile path, but instead tile path will pass down color. So we can set the color of the player object. And so we'll do, instead of self.tilePath, we'll do self.color. Oops. And in case you're wondering what a self is, I was looking that up on Copilot, and it's telling me that self is a reference to the current instance of the class. And so it's just kind of a Python thing, and a lot of functions that are referencing classes within itself use the word self to reference itself. It sounds funny, but that's kind of how it is. That's all we really need on the init function. I'm not going to do this. Delete all that out, and that's all we really need there. But we do want to define a move function, so we're going to create a move function. It's going to have itself referenced. We're going to set the direction and the distance that we want to move. So imagine if we're going to move up, down, left, or right, and how many pixels we want to move in either of those directions. So we'll say something like, if the direction is 0, then we're going to say self.x plus equals distance. Else, if direction is 1, this is just to get us started. It's elif. If the direction is 1, then self.x plus minus equals, distance. And then we'll need to put in the other directions too, and we can define those directions in our settings file once we get it working. And then we're going to need to draw, and I thought we would start out drawing the object as a rectangle. And so we'll do self, and then to draw a rectangle we're going to need a surface. And so what we're going to do is go Pygame dot draw rectangle parentheses surface self dot color. So we're going to draw out the color that's passed down. That's what that self parameter is for, so we can reference the variables. It's one of the things we can use it for. Comma, then we need a 4-part variable to make a rectangle. We need an x and a y and a width and a height. So we go self dot x comma self dot y. So that's the x and y. I think it's the top left corner. We're going to need a width and a height. So we'll go, just to start off with, 100 comma 100. And then if we do, for the border, if we do a 1, it's going to do an outline of the frame of the rectangle. If we make it 0, it'll fill it with the color. So let's try it with just the outline. We'll save that. And then what we want to do is go to the game object, and we're going to need to instantiate, or if that's the right word, we're going to need to call or set up the player object. We're going to have to import the player class. And then right here in it, I'm going to go ahead and do a self.player is equal to player.player. And then we're going to pass down the position. So we could put it anywhere in the map. We'll go with settings dot blue. So I have some colors set up in the settings file. Let's look at it. We could go with any of these colors. I'm just going with blue. And make sure you're saving. Make sure we're saving as I go. And then the next thing we need to do is have a way of moving the object. Some kind of a way we need to be able to move it. And to do that, it's in the events of the game object. And you'll see here we have there is some checking here to check to see if you hit the X on the window to quit the program. But we're going to go down here and we're going to set a variable keys is equal to Pygame dot pg dot, I think I have it abbreviated up there, key dot get pressed. So this will set up an object that has the keys that are pressed, and then we can say if keys bracket key underscore left colon. So if the left key is pressed, self dot player dot move 0 comma 5. And so what will that do? That tells you which direction to move and then how many pixels to move. And then we'll copy that and we'll do the same thing for right, except we'll make it 1 comma 5. So then in the draw function here, how the draw function works, it fills the screen with the color. That's where the green's coming from. Draw the game map, and then the next thing we need to do is draw the player. So we'll do self.player.draw self.screen. That's that surface. And if I did this properly, that should be all we need to do. We'll go ahead and run it now and work through any errors. Oh, I I forgot to rename the object at the top. I'm just going to go with player. I'm not going to put any parameters in yet. I'm going to change that later. So now let's run it. Oh, and you see it down here. And I have I'm pushing right and it's moving left, and I'm pushing left and it's moving right. So it's there, but it's weird with that little wireframe. So I'll go ahead and make this 1 to a 0 to fill it. And let's reverse this. So when we push left, it actually goes left, and when we push right, it actually goes right. And eventually I could set these up, and do set these up as settings for left, right, up, and down. Oh, and while we're at it, why not resize it? It's a little big. Let's go 50 by 50. And run it. Oh, and so now we have the problem where if I hold the keyboard down, it still doesn't move. I have to keep pressing. But it's moving, so we have an object that moves. Now all we have to do is implement up, down, in addition to left and right to get this sort of working. And so you kind of just build on. This is how you get started. You sort of build onto this, and then eventually you'll get it to where it automatically is falling. That'll be the next thing that we would have to do to make the player object work. There's a lot more to do, of course, with the maps and all the characters and colors and everything, but let's kind of go on to that to move in the object a little better. So the first thing I think I want to do is go ahead and change, instead of using draw, I just wanted to show that you could use a rectangle, but instead I kind of want to use an image similar to how it's doing it in the block. I kind of regressed it a little just to show how it's done. But I'm going to go ahead and put it back in up here, the parameter Pygame.sprite.sprite. So I want to start using the player as a sprite object. I also want to pass down the game object to the player for later reference. Have an X, a Y, and a color. And then down here, we're going to have to do a self.game is equal to game. So we pass that down. And we're going to put a few other commands in here in the init. We're going to put back the super, put back this command, and I'll try to explain what that does. This has to do with the inheritance and how it works in Pygame. And pretty much since I'm so new with Pygame and sprites and how it does it, I just know I have to put that in for this to inherit the object and for it to initialize and call this class. So it's just something I know that I have to put in, and apologize I don't have it completely down exactly how everything works, but I know we need it. And then we're going to initiate the image. We're going to go self.image is equal to pygame.surface. And then here we're going to define, just to make it a little different, we'll make it a 25 by 32. And then we're going to fill that image. So we'll do self.image.fill with the self.color. So that color that's being passed down. And then we're going to set up a rectangle. So self.rect is equal to self.image.getRect. So that will set the player object rectangle attribute to be the rectangle of that image up there. With that, we can set the X and Y positions. So we'll go self.rect.x is equal to self.x, and self.rect.y is equal to self.y. So that pretty much sets up using an image rather than drawing a rectangle here. So we can eliminate this code. We could either hit Control / to comment it out, or we could delete it out totally. And then while we're at it, we might as well put the up and down directions. And we can do this either with else ifs, or we could use like a select kind of a statement. And there's many different ways, but I've kind of started down this path, so I'm just going to keep going. So I'm going to go L if direction is equal to 2, self.rect or self dot, yeah, I think I'll change it to rect. Rect dot y plus equals distance. And then we'll change these to rect, just to be more explicit. Elif. You don't really need an elif on the last one, but we'll put it in there. Direction is equal to 3 self dot rect dot y minus equals the distance. For this object, we're good. I'm gonna hit, oops, cancel. I'm gonna hit save. But now that we've changed the parameters here for the player object, I think it's be prudent to change it over on the game side where it's instantiating it. And now we're going to make it since we're turning it into a sprite. What we want to do is we're going to move it for one. We're going to Control X to move that, and where the game does a new is where we'll put it. So we'll put it right after the read level. And we'll get rid of some of this blank space. So right here is the read level is where the map is drawn, or where it reads it into memory. We'll do player, we're gonna do self, comma, and then we'll have the X, the Y, and the color. Basically it's the same except we're putting in self. We need to create a player sprite group. So we have all sprites, we have game map, which is sprite group. So we're gonna do a self. We're gonna create one called player sprites. Player sprites, pygame.sprite.group. So a sprite group is just a collection of sprites, and eventually there could be more than one player sprite. There's obviously more than one game map sprite, and then all sprites just has them all in there. And then once you instantiate the player, we want to add it into the player sprites. So the command is self.player sprites.add self.player. So we instantiate it here, and then we put it in right here. Now to make this move up, down, left, and right, we're going to need to do a few things. I'm going to highlight it and do Shift Tab to bring it back so it's in line with the for loop, and that should correct the problem we were having where you have to keep pressing up or left, 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 left. And let's put in some more parameters here. Let's just move it 1, let's just do 2 pixels at a time. And we'll do a if keys key underscore up. So if up is pressed, then we're going to go self.player.move 3, 2. And essentially we'll copy that and change it to down. And we'll move it 2, 2. And then in the draw function here, we fill the screen green, we draw the game map, we draw the player, but instead of drawing the player here, because that's how it was doing it before, we're going to go self.player sprites.draw self.screen. So we'll save that, we'll save player, and we'll see what errors we get, or if it'll run. So I have a typo here. I need a uppercase S here. Oops. So let's fix that, see if we'll run. Just from this, you can see on these few examples here that I messed up the case in a few places. Notice that these are capital G on group. This also needs a capital G. So you have to be really careful. A little more careful when I'm being. Let's see if that will make it run. Okay, so we have another problem here. I think it's a case issue again. Let's see, surface. Surface has to be capital S. Is that what's wrong? We'll run that again. Aha, so now I'm pushing right and I'm holding, pushing left and I'm holding, pushing up, down, and left. And so you can see we have the beginning of something. We have the beginnings of something, which is neat. And from here, I think what I would want to do is player collision, because the next thing you want it to do is automatically sort of fall until it hits a block or something, until it hits an object, and you want it to stop. But we don't have that. So you have to build in some of this stuff. All has to be built in. Let's hit that up on this next segment here. Alright, so now in this segment, what we're going to go ahead and do is you'll notice here that the player is moving around, and if I'm not pressing any button, he just sits in the middle of the screen, he doesn't move. What I want to do is sort of implement maybe a faux gravity. It's not real gravity, because what I'm going to do is just add 1 to the Y position to make it fall down, so that when he goes ahead and collides with an object, he'll stop moving. But real gravity would entail that it falls faster and faster and faster the further he goes, and a little more mathematics to it. But we're just going to do a very simple implementation here really quick, and let's get started on that. In order to do this, we're going to go into the player object, and we're going to go ahead and implement a update function, and we're going to have to set a new variable called falling. So we'll go in here, we'll do a self.falling. We'll make it equal to true so that the player object is always falling when it starts off. And then we're going to create an update function. In fact, we'll get rid of this. We don't need this here anymore, and we'll just go ahead and do a update function. We'll go def update self. To get started, what we'll do is we'll say if self.falling is true, or you could just say, you know, without the is true, you could do it like this. So if we're falling, then self.rect.y plus equals 1. And so let's start with that, okay? And then we'll try to implement collision. So let's double check that over here in the game object. Now that we added this update function, we're going to go ahead, and right now down here it is just doing a pass. It's not doing anything. So we're going to go ahead and we're going to say self.player_sprites.update. So we're just going to call the update function so that every time in the game module when it does an update, it actually will run the update on the player sprite. And with no collision, this is just going to make the object fall straight down, I think. So let's try running that. Even if I'm moving left or right, there's no collision. I can push up to counter it. So you see where this is kind of going. If there was collisions enabled, it would stop. So now there's several ways to do collision in Pygame. The first methodology that I learned earlier on in my previous video that I did, that was like the Robotron clone, I used the method called group collide. That's how I start with this one. I'm going to do it like a group collide. So let's go over here in the update and let's expand upon it. We'll create a variable here, game group is equal to Pygame .sprite.group collide. And I know you don't have to use group collide here, but that's how I first learned how to use the collision. So I'm going to start with that. Self.game.player_sprites. So the first object that you're testing it against, and then the map. So you want to go self.game.game_map, and then false and false. And false has to be capitalized. And what that's going to do, it's going to return true if there's a collision, and it'll return the object. If game group, then let's go self.rect.y minus equals 1. So we're going to subtract. If there's a collision, we'll subtract 1. And then if there isn't one, we'll just say self.falling is true. And right now we don't really have a false in there. And let's save that and run it. And you'll see it right there. It's not perfect. I press up and it just goes up, 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 up. And it goes quicker if it's touching something. And then if I am not touching anything, it just goes down. And it does collide. You see it stops right there. And left and right, it moves. But there's a few little quirky things with it. But that is the basic of just getting the player object colliding with the game map. And it's kind of neat. There's a lot you could do with it. We could automatically make it climb. We can automatically make it climb if we do some testing, and I'll show you what that looks like. Right now, it doesn't necessarily make sense to do it, but let's try it anyways. So if we were to want to check a few more things right here in this if statement, where if there is a collision, we're inside here. We could even put a comment, collision. So we could do a for loop, for block in game group, and then we could check. So like if the player's self.rect, the rectangle, the bottom of the rectangle, if it's greater than the block that it touched, the rectangle dot top, what we can do is we can say set the rectangle dot bottom equal to the block dot rectangle dot bottom. And then while we're at it, turn off falling. Gotta have capital. And so there's all these different objects of a rectangle. You have top, bottom, you have top left, bottom right. There's several attributes of a rectangle object that you can utilize. Let's save that and run this. And so automatically you see it went up as soon as, because as long as if it touches an object, then it goes up. It's kind of useful. It's kind of neat. Like if it was an escalator, that's what you would want it to do. You don't want to do it on a ladder. You want that to be the player's decision to go up. But it kind of makes sense on a ladder. But more or less an escalator make more sense. And it is moving kind of slow to fall. You probably want to do more than just +1. And then you notice when you hit up, it's adding 1 to the movement, so it moves up quicker if you're pressing it. So not only does it have an up motion, but it goes quicker when it touches something because the collision is causing it to go a little quicker, to subtract 1 from the y. And so anyhow, you can see where this is going. You can do a lot of stuff, and that's just with the group collide command. There's a sprite collide, there's a rectangle collision, there's other ones that you can do. And I would think that the group collide is probably less efficient than if you were to do just a sprite collide. But once I figured this out and I got this working, I felt like I was well on my way. My intention with this video, I wanted to cover the animation of the game map objects, but I think the video is running too long and I'm not going to be able to get to it in this video. So let's see, I'm going to run the program. And anyhow, what I was getting at is thank you for watching, and we'll do a little bit more on the next video, and maybe you'll learn something with me.